Today we'll be learning about model evaluation and performance metrics. We touched upon this in the previous lecture when we learned about the logistic regression. So let's get started. Today we'll be learning it in a little bit deeper. Okay, so objective of this session is that you need to understand why model evaluation is essential, what is confusion matrix and its components, key performance what are key performance metrics such as accuracy, precision, and recall, and how to compute these metrics in Python. Okay, so why model is first of all, why evaluate models? Okay, so model evaluation helps in determining how well model performs well on unseen data. It happens every time, like you train your model on some kind of data, okay, and then when you deploy it or test it on some kind of unseen data, it may perform on well or not. Okay, most of the time, if you trained it properly, it may perform on well on some kind of data, but the real world data is very different. Okay, so you have to keep it in mind, like it may underperform in the real world data, or it may may look like biased or biased towards some kind of data. For example, if I train a model to predict whether given fruit is apple or not, okay, or let's just say classify the model into three categories: apple, banana, and oranges. Okay, so it may during testing it may look like the most of the time uh, the model is classifying fruit as banana. Okay, and some of the time it classifying as a fruit or apple or orange, but most of the time whether it's banana or not, it's trying to classify the model to banana. So it is called biasness in the model. Okay, and sometimes what happens, like model may also crash on some kind of unseen data, or like data you haven't trained upon but it's present in the real world, and at the time of testing you pass the data through a model, so it may give you a very wrong output in that case. So for in that cases, model evaluation is very important before you deploy a model, or before you uh, send your model to the real world testing. It is very important to first of all evaluate models on your end, like how to like what kind of performance model is showing. Okay, so in this case, we do is tune the parameters of the model, which also may called hyperparameter tuning. Okay, so it is very necessary for a model. It's basically a step in entire model life cycle. Like after training the model, we need to test models, I.e. evaluate the models. Okay, so it helps us finding a right metrics on the basis of uh like what kind of model it is. Okay, or what kind of model we are trying to build. So what is we go to the confusion matrix now. It is basically you can say a evaluation uh, chart, or you can say evaluation testing, in which all the data points of a trained model fall into. Okay, so whenever you try to classify the model, okay, whenever you try to classify a model, the results of that model, whatever results the model gave, will always fall through these four categories. Okay, either it is either the model that is given a positive result. For example, like if a model is giving a positive value and it is actual a positive value. Okay, for example, if you go to binary classification, and suppose the output is 1, the actual output is 1 in the test data, and your model is also predicted data output is 1. That will fall into the category of true positive. Okay. And suppose the actual output is 1, but your model is saying that output should be 0, then it will fall into the category of true negative. And if the output is 0 and your model is saying it's 1, then the data point will fall into the category of false negative. Okay. And if the uh, output is 0, but a model is also showing 0, it will give into the category of false positive. Okay. So this is like it is a classification technique so that we can deeply classify all the points that a model is predicted or to basically classify the model output. Okay, it basically provides us the counts of prediction outcomes, like what kind of data is there. So first of all, we will look into accuracy. Okay, accuracy means like what is the overall uh, performance of the model according to the test data, or how the model is performing on the uh, test data that we provide. It is a very first you can say very first test evaluation method that we use in classification. Okay, so as you can also see that the overall formula of accuracy is basically true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Okay, so uh, let's uh, roll down a little bit. Let me show you the table of, first of all, confusion matrix. Okay, so if you are able to see my screen, it is a true positive. Oh, sorry, confusion matrix table. So as I explained earlier, what about all these mm, categories hold? So you can also learn about that, like read an article on that because it is somewhat complicated topic and it may take time for you to remember it. Okay, and so let's get back where we were according to the accuracy. Okay, so let us repeat that again. So accuracy is basically very first measure of the or you can say very first method of testing for the model that has been trained. Okay, so what are the pros of this? It is simple, okay, and intuitive. And cons can be that it is misleading or misleading for imbalanced data sets. For example, suppose you have binary classification data and you have around 700 uh, 700 records in which outcome is 1 and 300 records in which outcome is 0. Okay, so the balance in the number between ones and 0 is off. Okay, so it is called imbalanced data set. Okay, and the balanced data set would be where in 1000 out of 1000, 500 will be 1 and 500 will be 0. Okay, so that is called the balanced data set. Okay, So it is a very first method, and most of the use cases we will either look into the precision or the recall. Accuracy is a very surface level testing evaluation method. You can check the accuracy of the model, but it may not give you uh, the entire picture of the model based on the use case you are working on. Okay, so this is a formula. You can see it on the screen. Okay, now we have precision. Okay, and what actually precision is, like how many predictive positives were actually positives. Okay, as you can see in the formula, we calculate precision by true positive divided by true positive plus false positive. Okay, so basically that means is like how many, for example, how many let's just take example first. Suppose we have a data set, and out of the 1,000 records we have few records which says as the outcome will be yes, and few records saying the output will be no. Okay, so out of the yes records, or you can say one record which have output 1, how many are actually 1 which are predicted by the model? Or you can say, let me take you another data. For example, we have some called medical data set. In medical data set, if the patient is have some disease, okay, so out of the patients who have disease, how many model predicted correctly that yes, people have diseases. Okay, so this is called precision. Okay, out of the how many positives you can actually predict how many positives are there. Okay, it is basically used when the false positives must be minimized. For example, in the medical data set, that as I was saying earlier, like out of the patients who have disease, how many models have actually predicted yes, they have a disease. Okay, suppose you have like 1,000 patients who have a disease, and model will be able to uh, predict around 950. Like out of 1,000 records that are positive, model predicted 950 people have disease. So the precision of that model will be 95%. Okay, these are basically used in the medical or email spam detection model, or in the use cases. Okay, like whether you when your Gmail uh, by itself classify the mail as a spam, so you found that in the spam folder. So how it is doing, or what is the evaluation model that Google used before deploying the model in your phone? Okay, so precision is the method where we required highly uh, accurate or highly positive classifying data. Like we can't be we can't let even one mail or one uh, misdiagnosed patient leave. Okay, so next is recall. Okay, what this recall means is actually how many actual positives were correctly predicted. Now many people get this confused with always get this confused with precision. Like we also learned the same thing in precision. What is the difference between precision and recall? So basically the difference is, as I was saying earlier, precision is like out of how many positives, out of all the positives in the data set, how many positives that the model predicted. Okay, this is called precision. And what recall is, out of the out of the records that the model has predicted positive, how many were actually positive? Okay, it is you. So basically, what I'm trying to say here is like how many, like suppose uh, out of 1,000 records, model predicted around 900 to be positive. Okay, but so the recall will come when out of those 900 positive records that model predicted, which were out of thousands, how many of those 900 were actually positive? For example, if you have 1000 records and model predicted, let's say 900 that are positive, okay, but the actual positives in that data set is around 800, okay. So 900 is misclassified as positive, okay. So that's where we calculate the recall. Like out of model, out of the positive that model predicted, how many were actually positives? Okay. So if model is predicting 900 records to be positive and there are 800 records to be positive, so accuracy will be 8 by 9. Okay. So so y- basically recall is used when false negative must be minimized, which means we have to minimize the records where we're trying to predict the mod then where the model predicted to be positive but it's actually negative. Okay, for example, you can see on the screen cancer detection. Okay, suppose now if a patient comes to you uh, that he thinks that he may have a cancer, and you use the model that you created, try to predict whether actually a patient has a cancer or not. Okay, and now suppose you have 10 patients like that, and out of the s- 10 you predicted like 6 patients have cancer. Okay, but it may happen like it may happen that either only 5 people have cancer out of 6 that you predicted and one you have given the false report, or uh, out of 10 9 people have cancer but you have predicted only 6. That means you have misclassified 3 patients. Okay, so this is where recall is mostly used, like in the disease detection. Okay, like you don't want to give a patient a false hope that he does not have a cancer, or you don't even need to give tell the patient like do you have a cancer, but actually he doesn't. Okay, and it is all okay. So this is where we can focus more on recall. Okay, and another example of that would be another example where recall is used could be fraud risk alerts. Okay, for example, you do online payments. Okay, so on online payments, suppose you are on tour in another state. Okay, and you try to make a payment there and your payments get blocked because you haven't because most of the time you live in your hometown, and all the payments are done from there. So the model at the bank side may classify this as a fraud risk, that someone is trying to pay through your account in, let's just say, uh, Madhya Pradesh. Okay, you are in Madhya Pradesh, you are trying to make a payment from there, but model may classify this as a fraud risk and try to block your payment. Okay, so in that case, there's also model giving giving a result where it is wrong. Okay, so to improve that, during evaluation of that model, recall will be much important as compared to simple accuracy and precision. Okay, do do read definitions of recall and precision again, because many times some people get confused like what is the difference between precision and recall, because they get mixed up with the definitions of both. Okay, and F1 score. Okay, so basically what F1 score is a basically is a mixture of both precision and recall. Okay, you can see the formula on the screen. It's 2 into precision into recall. divided by precision plus recall. It is somewhat like harmonic mean of the precision recall. Okay, so it is useful when data is imbalanced, as I told earlier, whether the results of the amount of positives and negatives are not equal. It is imbalanced data set. Okay, and where in some use cases you actually need both precision recall to be high. Okay, so in these cases, F1 score, evaluating the model with the F1 score would be a right choice because you need a metric that combining both of their strengths. Okay, so these are the evaluation methods which you can use to evaluate your classification model. Okay, now let's go to the code and see the example there. Okay, so let's go to the code. Uh, Here I've already written these libraries. Okay, so we will run them. Okay, so libraries have been imported. Now we will what we'll do is write like just for this example, we will create two arrays. Okay, which will be we will give them name of y test. Basically, this is a test data. We will just use one zeros for binary classification. Okay, and now we will also give some random data which will be taking as a uh, prediction predicted by model. Okay, so okay, so this is a model. Okay, this is random data. When you will train your own model, you will also get these y test and y predict. You can refer to the previous lecture on classification, lecture number I guess 36. Okay, so you can refer that. In that video you have the entire procedure how to train a model and predict and evaluate that. Okay, for this lecture we are just taking these random arrays. Okay, so now what we will do is accuracy score, and here we will give a accuracy score method that we imported from scikit-learn, comma y red. Okay, similarly we will also give precision, comma y red, which is by prediction. Now we will write recall. Okay, and at the last we will also look for F1 score. Uh, And at the last, first of all, let's print all of these. Okay. So as you can see, we have accuracy of a 37, 0.375, which is 37.5%, which is very, very low. Okay. And precision 0.6, 0.5, and f1 square 0.5. Okay. So this is a random data when you will try to train your model. Okay. When you will get the outputs by a model, you will able to actually, so you will able to find out the real accuracies. This is some random data. And the procedure in that case will also be the same as I read in this column with the print statement. All of these, you just need to import using scikit-learn matrix. Okay. sklearn.matrix, import these. And now we will look into confusion matrix. Okay. So basically confusion matrix, we will pass on the same arguments as we did with all accuracy, precision, recall, and F1. Okay. So this is your uh, confusion matrix. Okay. It is 2 by 2. It is basically will show you like this. Uh, Let me look in that. Yeah, it will actually look like this, where you have the true positive, false negative, and false positive, all that. Okay. For there's also a method called. I will import that so that you can you will able to easily understand SQL from sklearn dot matrix import uh, display, not display, confusion matrix display. Okay. So it is able to it will show you in a it will show you a confusion matrix in a visualized form. Okay. That you can see it in a better way. So for that, I will also need to import from Matplotlib, not from, import matplotlib.pyplot splt. Okay. Now I will create a variable called CLF and pass this confusion matrix display from predictions y test comma y red, which is by predict. Leave the from predictions. I will basically give here uh confusion matrix is equals to, let me put that in a variable so it be easier. Which is, I will give a CM. Okay. And next I will give only, I will give confusion matrix here since I haven't trained the model here, so CLF to classes will not be useful. Okay, so CLF dot plot, okay, and PLT dot show. Let's see what happens. Okay. So this is a confusion matrix. Basically, you are in the bottom. You are you will be seeing the same color because both these both have the same values. Let me uh, recheck that. Change the value so that you can better understand. Okay. Yeah, now it's better. Okay. So as you can see, we have a visualized form of computer matrix here where we have true labels. True labels means what is the actual value. Okay. Here in the you can say y-axis we have the 10 here, which is a true value, which is given in the data testing array. Okay, y test array. And this is a predicted label, which is basically zeros one predicted by model. Okay, so you can see if we have both one in the true label and predicted label, we have true positive, which is value 4. Okay, and if we have true label as equals to 1 and predicted label is equals to 0, we have uh, true. Uh, what will we have? Uh, we will have a false positive. Okay, yeah, false positive. No, wait a second. Uh, let me refer that. Yeah, we will have a, if we have zeros and one, let me go back to a slide. Yeah, if we have true label as one and predicted label as zero, we will have false negative. Okay, which means the model has uh, falsely classified the data point as negative. Okay, now uh, here we have zero, which is basically means true negative. Okay, where model is also predicted 0 and true label is actually 0. So basically there is no data point which model has predicted 0 and is actually 0. Okay, so that's why we don't have true negative here. Okay, and we have basically false positive. Okay, where model has predicted 1 but the true label is actually 0. Okay. So this is how we use a classification matrix. You can do one more thing. You can also try to find a method where we can also write these true positive, true false negative, all these things in this visualization. Okay. So that is your mini homework so that you can understand like how can we uh, how do we understand these or so that you get a better practice out of this. Okay. So this is it for this lecture. Okay. So now you have a assignment for you, which is you have to create a model evaluation practice using binary classification data set such that you can take breast cancer, Titanic, or any of your choice. Okay. You need to train that in a logic regression model, generate the predictions, and uh, calculate these matrices out of this out of the result do you get, which result you get, and interpret which metric is the most important for the data set and why. For example, if you choose breast cancer, so you need to like justify like which of these evaluation method is the most important one. Okay, and so you can submit your Jupyter notebook in the form link below. You would have already had the form link, and that's it for the lecture. Uh, Thank you all.